Hello everyone. Today in this video I will be discussing about ADE module 1. It's not at all hard, just watch this video. It's very easy. I have made the things very simple and I hope you understand the concepts easily. So in theory exam, in exam the theory portion will be based from BJT, op-amp. It has 3 sections: filters and A to D and A to D converters. Okay, then second, numericals are asked from BJT, especially voltage divider, and these 2 topics: multivibrator, Schmitt Trigger, filters, low and high pass, regulator, very important, and digital to analog converter only. And these are the other things which are not that much important, but still it may come in exam. Okay, comparatively it's not that important. So I will be discussing each topic in very simple way, and all the topics are covered in this video, as well as in numericals. All the numericals I have taken some examples which if you see once it's enough for you, and in exams also only the similar things will be asked from each of these topics. So let's get started. So the first topic which you have is BJT. It's among the 4 major topics which we have in our syllabus. BJT is the first topic among them. So in BJT there are 3 terminals, as you can see in this diagram. One is for input, one is for output, and another is common terminal. Okay, normally circuits have input and output, no, but in this it has input, output, as well as one common terminal. It is used for both input and output. Okay, and for numericals, keep in mind you have to focus on these 3 values: IC, VCE and IB. Okay, now there are 3 types of BJT. These all diagrams are very simple. Look here, see, first one is fixed bias. In fixed bias, VCC is here, and always the supply voltage starts from VCC, and from VCC some current comes, right? So the current gets divided at this junction through RC and RB. In RC the IC gets passed and IB gets passed in RB. So if you trace back at this point, the current should be IC plus IB. So VC releases IC plus IB here, and the IC will come here and IB will come here, and this thing I will be explaining in numerical part. And in collector to base bias, it's same as this, it's identical, but just RC has shifted from here to here in this one, and RC will have the voltage drop by the current IC plus IB. That's the only difference between these 2. And coming to the third one, the upper half is same as the fixed bias. As you can see, you can pause the video and observe, these full things are same as here, right? And the bottom part, just 2 things are more: R2 and RE. That's it. These 3 are the types of BJT, and I will be discussing the formula and how to solve those things in the numerical part. The main thing when they ask in exam is Q point. Q point means IC, VCE. You have to find IC and VCE. They will be giving example in numericals. They will be giving VBE, VCE. We have to find IC and IB. That you can use formulas and find out. That I'll discuss in the numerical video in detail. Okay, so now the second thing which we have in our syllabus is op-amp, and op-amp has 3 categories: multivibrator, peak detector and Schmitt trigger. Okay, op-amp is the second one. First one was BJT, it's over, and this is op-amp. It has a numerical and theory part, but here I'll be discussing just the theory part. So let's get started with the first one, multivibrator. It's very easy. Just listen to this video, you will only believe in me that it's very easy after watching this video. So I hope so. So what is multivibrator? Multivibrator is nothing but we have the police siren and ambulance siren, the blinking lights and all, right? So what we do, if we want to blink a light, we can switch on and switch off, right? But what we want that to happen automatically. So what we'll do is connect the switch with a multivibrator. That multivibrator is something device which will make the light blink with at particular time and off at particular time on. Like that it gets repeated. The timing can be set by changing the values of resistor and capacitance. So let's get started with multivibrator. We have 2 types of multivibrator: monostable and astable multivibrator. Okay, before getting started with this, we have to first see the main component used in the multivibrator, which is IC 555 timer. Okay, this one is very easy. This is the most simplified diagram which I have drawn, excluding all the other unwanted pins, and this is only the required thing which you are supposed to know about. Okay, now see, observe here carefully. These are 2 op-amps. Okay, and this pin negative is connected to the negative terminal here, and pin positive is connected to the positive terminal here. Okay, and this VCC where we are sending the voltage, this current gets passed till here and it gets the ground. Okay, so now you understood there are 2 op amps and 2 pins which are connected to positive and negative, and the VCC along with the resistances is here, and R and S, this I will explain, and here is the output. Okay, now see what will happen if we will increase this minus. Okay, minus means if you will increase the voltage here, this here it's negative, so what will happen, this will get increased. If it increases more than this output will be low, because this is negative, right? Negative terminal, if the voltage increases, the output will be low, so low output will go to S. Similarly, if positive is there, positive is more than VCC at here, VCC is coming here, right? So if the positive pin we are applying more voltage, then this will become plus, and high output will go to R. But actually what it depends on the output, final output only depends on S. Whatever be the value of R, it doesn't matter, only the value of S depends. Okay, so you will understand it better when we will consider the case of monostable multivibrator. What happens in monostable multivibrator is, assume there is a river flowing and we put a log in it, so the river flow gets disturbed and low water comes out of this. So what happens when this thing happens, the sensor will give a signal that output is high, means it's giving a signal that something else has happened, means something disturbance has happened. So this is the same thing in multivibrator. Firstly, a monostable multivibrator, what it does is, it is when something disturbance happens, the output is high. When everything is fine, the output is low. Okay, that's only monostable multivibrator. Now let's start from here. Don't think anything about the whole graph, you will get with the flow. Just listen to from starting here. Pin negative. Okay, first the everything is normal here. Pin negative, normal voltage is going on, so the output here is more, means we are applying some voltage here, so in negative voltage is getting applied and it is more than that of positive, so the output here is low, and so S will be 0 and the output will also be 0. Another thing you need to keep in mind is, when output is 0, that time what happens is, this is called the transistor. Okay, transistor, when output is low, the transistor will discharge, means what all the charges will be in the capacitor, it will pull towards it and it will discharge it. Okay, that's what the job of transistor is here. So initially everything will be normal and the output will be there, and the transistor will be discharging everything. If capacitor has nothing, it will not discharge anything. Now assume some error has happened, means some log came. In this case, like in river, we reduce the voltage here. So when we reduce the voltage here, what it does, it gives a high output. How it will give? See, when it reduces the output voltage here, then positive becomes more here. When positive becomes more here, what will happen, this output will be high. When this output will be high, then S will be 1. S will be 1. So when S will be 1, it only depends on S, output depends on S, so output will become high. Okay, when output will become high, discharge will not happen. As I had told you, if output is high, discharge will not happen. If output is low, transistor will discharge all the charges. So it will not discharge, transistor will not discharge, and the VCC, the supply voltage, is coming here also and it's coming here also. So when it goes and flows here, it will charge the capacitor here. Okay, then the capacitor gets charged here, and until the disturbance again it is removed. Okay, this gets charged. Okay, what happens when it is removed? When this is removed, then again it will increase. When this is removed, right, the like river flow will again increase. When this disturbance is removed here, again the voltage will increase here and increase, and this minus will become more than that of this, and again the output will be low. Okay, when output will be low, because S is low, output is low. When output is low, what happens? The transistor will discharge. So all the charges stored here will discharge here through the transistor. Capacitor will become empty, and output will become 0, and everything normally how it was initially, like this was minus, right, and charges were going here and the output was 0, and this again after removing that, the output will become here 0. Okay, that's the monostable multivibrator. So in short, what happens is, if any trigger occurs here, then this minus, what is connected with here, this will become less, because this river is flowing, voltage is flowing here, when something trigger happens, reverse flow becomes less, voltage becomes less. When voltage becomes less, this will become less, so plus is high, so the output will be high. When output will be high, then the transistor will not discharge anything, so transistor will let the flow of current here, so VCC will flow and the capacitor will get charged, and the output will be high only because the transistor is letting it charge and the output is high. Then when this log is removed, when the disturbance is removed and the initial voltage is again applied, negative becomes more than that of positive, the output will be low. When output is low, the transistor will discharge all the charges. When transistor will discharge all the charges, capacitor will become empty, and as usual, as initially, the minus was more here, and the normal voltage what was being applied initially, that will be same as here, and the output will also become 0. It is low, so the output here will get as low. So what happens, only when the disturbance happens, it gives a triggering signal. Okay, so we can use this technique in any sensors. If something disturbance happens, we can know by the blinking of light when the output is high, at the same time when the disturbance happened. So this is the working of monostable multivibrator and the application of monostable multivibrator. Okay, coming to astable multivibrator, this is the same thing, but what happens, we are not controlling anything. In astable multivibrator, it gets automatic high, low, again high, again low. Okay, that's the only difference. And here also it's the same diagram, everything is here. 2 op amp are here, RS output, VCC is coming like this, VCC is coming like this, and the transistor is here, and here also transistor is there. Only difference is here resistor, here resistor is not there, and this C is being pulled down here. Okay, that's it. Pin 2 is a pin minus and pin plus, both are connected with the C. So the working of astable multivibrator is like this. We can start from C. Okay, no charge is there. Okay, if no charge is there, this here it's 0, here also it's 0. Okay, so when here it's 0, this is negative is 0, so the output will be high, because this plus is here, plus is more than that of 0, so the output will be high. How this plus is more than that? Because this is connected to VCC and we are providing some current in VCC, and that current is coming here and this is going till here, and the positive is more than that of negative, so the output will be high. When output is high, S is 1 and the output will be high. What happens when output is high? Transistor will not discharge, it will let the current flow. When the current is flowing, this capacitor will get charged. While charging the capacitor, this point and this point, the voltage will increase. What will happen when the voltage will increase at these points? When the voltage will increase, this negative will increase. When it crosses what voltage is here at positive, when it crosses that, S will become negative, means low output. When the output is low, what will happen? It's 0, transistor will discharge all the charges stored in the capacitor. So again all the charges will go, and this point voltage will become less, this also voltage will become less. When voltage will become less here, what will happen? This is low here and positive will be more, so again the output will be high. When output is high, the transistor will not discharge, it will let the current flow and it will again charge the capacitor, and the cycle repeats again. So this happens automatically, and we can adjust the timing, how far this should be and how far this should be, how much time it should not blink and how much time it should blink, by adjusting the values of capacitor and the resistor. Okay, this is the astable multivibrator. Okay, now the second application under op amp is the peak detector and Schmitt Trigger. Okay, after this two, the second part will be over and two more things will be left, that is filters and A to D and D to A converters. Okay, then the theory part is over. So let's begin. What is peak detector? Peak detector means when voltage will increase, this value will be retained. Again, if it decreases, it will not decrease, the value will be retained. And again, when the voltage will increase, the maximum value will be this, and peak detector retains this value. Okay, this is known as peak detector. Now let's see how it works. See, in peak detector, forget about this part, I'll explain it later. Just concentrate on this part. In this part you have three components, one is capacitor, one is diode, and one is voltage. Okay, so initially the voltage is increasing, okay, means it's positive. Here voltage is negative, here it is positive. Okay, when voltage is increasing, it's positive. So what will happen? voltage is positive here, and the diode positive is connected with positive and the negative is connected with the negative, means grounding. Okay, so voltage is positive, so the diode is forward biased. So what happens when the diode is forward biased? It starts conducting and the charges will get stored in the C capacitor. Okay, all the charges will get stored in the capacitor, and what happens here? Nothing, it's nothing, just the charges will go here also, and it will feedback, and our output will also be the same. Means as it's increasing, the output will be like this. But now let's see when the charges become negative, means the voltage starts decreasing. When the voltage starts decreasing, here it's negative. Okay, here it's negative and it's positive here, so it's reverse biased. In reverse bias, what happens? The diode will not conduct, because it is measured, the current which we get in reverse bias diode is in microampere. It's very less, and it's very negligible, so it will not charge the capacitor, nor it will discharge the capacitor, and the capacitor will hold the charges. Now like this it will go down, nothing will happen to capacitor. But when after this point the voltage again increases, then here more positive will come, more current will come, and it will get stored in this, and so the capacitor also will increase its charges and it will hold till here, and then when it will decrease, capacitor will hold the value. Like that only it happens. And this is just feedback loop, means when the charges come here, it will go to the output, and also the same charges will come and output come and sit here. Okay, means it will get inserted in this terminal. Okay, so that's nothing, don't worry much about this, just you need to know the working principle, which is mainly this. So this is peak detector. Okay, then you have modified peak detector. This is nothing, just the same thing, this same what I am seeing. See, I'm gonna cut this whole thing into two parts, right part and left part. This right part is here and this left part is here, and if I join these things, okay, means a resistor, another op amp, and another diode. Okay, if I attach this, it is known as modified peak detector, and what it does is it just provides a better result and better negligible losses will be less, and such things. Modified peak detector has better value. So how it works in this, it's the same working as this. So what happens when the input is normal, means the input is high and charges are flowing like this, and when this will go here, see, positive terminal. Okay, when the voltage is increasing, positive terminal, and this here current will go here also, and here it's negative. Okay, so this diode is reverse bias. Positive is connected with negative, so it is reverse biased. This will not conduct, this whole circuit will not conduct here, but here it's forward biased because it's positive, and the voltage was also positive here. So this is positive, it will conduct and it will store the charges. But when the charges will go to the negative, means voltage will become negative, this will become reverse biased, because see here, when the voltage is becoming lesser, this is negative here, so, and this will be not conducting because it's positive and it's reverse biased, and this will be conducting because it's forward biased. Negative is connected with negative, and this, when it is reverse biased, what will happen? No, now it's forward bias, right? Yeah, so when it's forward bias, it will conduct, and the current will come here and go to this terminal. So it is providing a feedback, and it will not go to negative saturation, means it is maintaining the value of capacitor charges here. That's it, it's not that important, but if you know the general principle that the charges will come here in forward bias, it will get stored, and when it's negative, it will not retain, it will retain all the charges, and if it increases more than the previous value, it will store more charges, and in reverse bias, it will not conduct and it will not decrease also because it's not conducting. It is preventing, the reverse bias is preventing this from getting discharged. Okay, that's the peak detector. Coming next, this is the last topic of op amp. In op amp, the Schmitt trigger. So what does a Schmitt trigger do? You have to remember this one rule. Okay, listen carefully, it's very easy. If you listen carefully, you will get to know. The output will be high, the output will be high if it hits U, and low if it hits L. This is the upper limit, this is the lower limit. Okay, now the voltage is coming here, the voltage is coming here and it hits the upper limit. Okay, so the digital output will be high. It was low but it hit the upper limit, so this became high. Okay, And again, if it comes below the U also, it's not a problem. It will be high only. How much time it will be high? It will be high until it hits low. If it goes below low, then the output will decrease here. It will become 0. Okay, then it will be same. Again, it will be becoming high only when it hits the upper voltage. See, the thing to keep in mind here is it goes below L. Okay, it goes below L and it goes above L also, but it has not yet reached again to U, so the output will remain low. That's the difference. So when it hits upper limit, the output will be high again, and it will be high only. And even if it crosses the U again, it will be high only, because it will only become low when it comes again and hits L. So it will become low after when it reaches L here. If it reaches L here, again the output will be low. This is the Schmitt trigger. Okay, so there are two types, non-inverting and inverting. In non-inverting, what happens? Let's see from this V in. Okay, V in, if we apply any voltage, okay, if you apply any voltage, the voltage will come here positive. Positive is more, this is grounded, so it is 0. Positive is more, so the output will be high. Output will be high. Okay, the output is here. And what will happen here is the negative has the value switching between U and L. Okay, so when the negative value is L, means lower, if the V in gets lower than L, then this will become more, this will become lower than L, so the output will be low. So the output will become low again. So like this, when the output will become low again, when it becomes low again, when it the V in gets lower than L. Okay, so again what it needs to do, it needs to cross this point U. It needs to cross U again to become high. So at this point what will happen? This will not remain L. This will get shifted to U. Why? This V in should cross the U to get the output high. If it wants to cross U, so this should be U, right? If it is L only, what will happen? If it crosses L, the output will become high. If it is more than L, if it remains L here, if it becomes more than L, output will be high. But that's not the case. See here, as you can observe, it becomes more than L. V in became more than L, but it's still low only. So this is the speciality of Schmitt trigger. If it hits U, then only it should become high. So this will be, get shifted to U. It will have U. So when the V in will again become U, means high value, then the output will be high. Okay, that's the working of non-inverting. In inverting, what will happen? The reverse of it. If this is high, output will be low. Why? Because V in, if it is high, higher than lower, higher than upper. Here upper, no, yeah, here upper. If it is higher than the upper, then this is negative. So the more you put here, the more negative, then the output will be low. So that's why in inverting, the graph will be reversed. In this point it will be high, then it will become low, then again it will become high, again it will become low. Like that it happens. This is the working of Schmitt trigger, and that completes the op-amp part. Now two more parts are left, filters and D2A and A to D converters, that I will be discussing in the next video. And thanks a lot for watching this video. If you have any clarifications or doubts, please let me know. Thanks a lot.